Hi folks, I have another lesson for you on types of rates of reaction. A rate of reaction can be defined as the change in entity or the change in quantity of an entity as a function of time. You can measure the rate of a reaction by measuring either the change of one of the reactants, in other words, consumption of one of the reactants, or by measuring the rate at which a specific product is being produced. In both cases, as long as you were able to find the rate of consumption of one substance or the rate of production of a product, then you can actually find out the rates of consumption or production for any of the other substances in the balanced chemical equation. And so this makes this tool a very, very powerful tool. Because if we are able to measure the rate of change of one substance, we then can use that to find out the rate of change of other substances in the balanced chemical equation. Right? So let's venture into rates. There are two different types of rates of reaction. And you may have heard of these terms before. Average rate. Average rate is when we have a change over a period of time. So we are looking at a range at which something happened and how much change happened, and we can take the amount of change divided by the time it took for that change, and that will give us the average rate. Right? Whereas instantaneous rate, again, you might not have heard of the term instantaneous before, but an instantaneous rate is different from an average rate of reaction. Instantaneous rate is the rate at a specific point or at a specific time of the reaction. Okay, so average rate is over a period of time, whereas instantaneous rate is at a specific moment. I'll give you an analogy. So let's say person A is driving on the road and he leaves his home at 9 in the morning and he's going to school. Okay, and it takes him 1 hour to get to his school, which is 40 kilometers away. Okay, so it took him 1 hour to get to school, 40 kilometers away. On average, we can say that he was driving at 40 kilometers per hour because the school was 40 kilometers away and it took him 1 hour to get there. So his average speed was 40 kilometers per hour. All right, because during that 1 hour, he only traveled 40 kilometers. Okay, so that is considered his average speed. But was he traveling at 40 kilometers per hour during the entire route from his home to school? Well, probably not. Maybe there were stoplights. Maybe there were signals that he had to stop at. Maybe he stopped at Tim Hortons to get a tea or coffee while going to school. Right? And if that was the case, he was not driving at 40 kilometers per hour during the entire duration of this route from his home to school. And his instantaneous speed at different points in time on the route was different. Sometimes it may be higher and sometimes it was lower, but overall it was 40 kilometers per hour. So the instantaneous rate is at a specific given moment of time. Another analogy you can look at is, let's say, when a cop stops a person who is speeding, right? So at that point, is the cop looking at the person's average speed or the instantaneous speed? Well, if you think about it, he is using his device to check the person's instantaneous speed at that specific moment in time. And let's say the speed limit at this road was 40 kilometers per hour, and the cop took the reading of the person driving at 60 and stops this person, right? So the person might say, well, I'm almost at school, I left at 9 and 40 kilometers away, my speed was 40 kilometers per hour. But that's the average speed. The cop is not concerned with his average speed. The cop is going to give him a ticket and say, well, you are driving at 60 kilometers per hour in a 40 kilometer per hour zone, for example, right? Because he is looking at, or he's concerned at with the instantaneous speed at that specific moment in time, not over a given period of time, just at that moment, how fast that person was driving. Okay, so there is the distinction between average speed and instantaneous speed. Average rate or instantaneous rate are different. Average rate looks over a greater period of time, whereas instantaneous rate looks at a specific moment. Okay, now let's look at this graph. So we have this interesting graph down here, and so let's look at what this graph is trying to help us understand. On this graph, on the y-axis, we have the concentration, and on the x-axis, we have time. Okay, and I have one line, one graph, and we can see that it's going down, which is the reactant, which is labeled as reactant. Initially, we had a high amount of reactant, and as the reaction progressed, the amount of reactant is coming down. Okay, that's one thing that we can notice. The rate or the amount of reactant is decreasing. We knew that. Chemical reaction takes place, reactant is going to be consumed, and the products are going to be produced. The other line that I have is the product line. And initially it was zero amount of products, and as the reaction progressed, we have more and more products being produced. Great. Now, we have that. We know the reactants are going to be consumed, products are going to be produced. But at what pace? The rate. Now, rate is important. To figure out the rate of the reaction, we have to look at, well, we can look at two different rates here. But if we are talking about the average rate of reaction, then we will have to find out on the graph for the reactant, for example, we will have to draw a straight line, and I'll write it here, straight line from here to there. That's a straight line, all right? So we have two different points of time, right here and right there, right? So this is our time 1, and that's our time 2. Okay, so we have time 1 and time 2. Initially, the initial time, it was high, and afterwards it was lower. Makes sense, it's a reactant. How much was the change? Well, let's see. I can draw the line for that here as well. Okay, and if you remember for your math class, you have rise over run. This is the change in concentration here. The change in concentration, which is y2 minus y1 over x2 minus x1, right? So this is y2 minus y1, and this is x2 minus x1, which is the same here as concentration final minus concentration initial over time final minus time initial. That will give us the average. So this is going to tell us the average rate, right? So an average rate is determined by drawing a secant on your curve. Okay, so when you draw a secant, it gives you the average rate. Now, if we did not want the change in rate over this long period of time between T1 and T2, and we wanted to know exactly what was the rate of change at T2, right? Instantaneous rate is at a specific moment. So at the point of T2, what was the rate? In that case, what we will have to do is we will have to draw a tangent, and I'm going to attempt that here, there. So we'll have to draw a tangent onto the curve, which is connecting to the curve at T2. And then we will have to find the rise and the run at T2. If you can find the rise and the run at T2, that is going to give us the instantaneous rate. Okay, so to find the average rate, it's over a larger period of time, and we are looking at the change over that period of time, whereas an instantaneous rate is the rate of change at a specific moment in time. Okay, so that's the two differences here. Now, that's now you have understood what the difference between average rate and instantaneous rate is. Some more piece of information that we can gather from these graphs is this. If you look at the rate of change of the reactant, initially, looking at the instantaneous rate, initially the slopes of the tangent are steep, and then it gets less steeper, and then less steeper, and then less steeper, and even less steeper, and less steeper. What does that mean? Well, since the steepness of the rate or steep of the curve is getting less and less steep, the instantaneous rate is going down. The rate is decreasing over time. Okay, so in other words, initially the reaction is very fast. As you progress in the reaction slows down. So the reaction does not run at the same speed throughout the whole process. It changes rate. It slows down. The rate at which the reactants are converting into products slows down as the reaction progresses. Okay, now I'm going to try to link it for you to collision theory or collision model. If you understand what collision model was, initially we had lots of reactants and there was a very high chance of these particles colliding with one another, and therefore the reaction rate was high. As the reaction has progressed, the concentration of the reactant has declined, and now the chance of these reactants colliding, the right reactants colliding with one another with sufficient amount of energy has declined with it. And since the chance of collision has decreased, the rate of reaction is also decreased. I hope this helps you understand what is happening to the reactants, right? So the reactant concentration has gone down, and therefore the reaction rate has also gone down. If you look at the products, same is happening with the products as well. If you look at the graph initially, we have a steep curve, less steep, less steep, less steep, less steep, and less steep, and then less steep. The steepness of the curve is declining, indicating the same information that we got from the reactant graph. Initially, in the beginning, the reaction rate was the highest. It was the fastest. The products were being produced at the fastest rate. As the reaction progressed, the amount of product, or the rate at which the products were being produced, declined over time until it slowed down, and at the end it will become zero when all the reactants have reacted to convert into a product. So again, initially the reaction is fast, and as the reaction progresses, the reaction gets slower and slower and slower. So if you were to pose a question now, at what point in a chemical reaction is the instantaneous rate the fastest? That would be at time zero. Initially, when the reaction just begins. So when it just begins, at that time, right, slightly over time zero, that's when the reaction begins. That's the point where the instantaneous rate is the highest. And as the reaction progresses, the rate of reactant converting into a product slows down over time in a chemical reaction. I hope this lesson helps you to understand the difference between average rate and instantaneous rate, looking at the graph and how we can use the graph to find the average rate of a reaction between time 1 and time 2, or finding the instantaneous rate of reaction at a specific point by drawing a tangent to the curve, and the key idea that as the reaction progresses, the rate of the reaction slows down. The instantaneous rate slows down as the reaction progresses. I hope you liked this lesson, and if you learned something from this lesson, please hit like, subscribe, and look forward to new lessons coming up in the future to have a better understanding of the chemistry concepts in the course.